All right, so what are we doing tonight, Brandon? Are you going to verbalize stuff, or are you going to send me something? Didn't get anything. Got to send it to my email. Here, let me put my email address up on there. Make sure you send it to this one. I've got a couple, and if you send it to the other one, it gets forwarded, and sometimes it takes too long to get here. Send it to that one. And tell me when it says sent. Not sending, but sent. Refresh me. What kind of math are you taking, Brandon? Okay. I got a lot of geometry students this year. Geometry is the most difficult thing to verbalize. Obviously, because, you know, you're dealing with shapes, and those are hard to verbalize. It's not like algebra. Algebra can be verbalized quite easily most of the time. What kind of, are you taking a picture with your phone and sending it? What kind of phone? The iPhone? Make sure you send it as a large file or actual image. Don't send it as a small file attachment. And it is better if you send it as an attachment, but just send it as a large file attachment. Okay. Let's have a look. I got two of them. Which one? Okay. I just got. Now this one's got multiple pages on it. Okay, let's see. Can I download? I assume we want to go from top to bottom. Okay, hold on. Let me see if I can. Yeah, let me get that one. And I'll be able to rotate it. This is question 25. Is this where we want to start? Well, we can start at 1. It usually makes sense to start at 1 on these things. And problem with doing them out of order is it's hard to remember. When is your test? Okay. Yeah, let's back up. And let's see if we can figure out. Let me look at this thing sideways. Let's see, that's 25, that's 41, that's 53, that's 64, 65, here we go. Yeah, let's start with this page. I think this will help. Hold on. I'm going to be able to download that file. Let me blow this up enough that I can read it, and then we can see these problems. So ST bisects MN. What equation can I set up to answer this? In other words, they're telling us that MA equals 3x plus 8 and AN equals 20. What do we know about MA and AN? Okay, up here, ST bisects MN. What does that mean? What's bisect mean? It splits it into two equal parts. So if these two parts are equal, then that is equal to that. And since the one on the left is 3x plus 8, and the one on the right is 20, gives us an algebraic equation that we can solve to answer this. Go ahead and solve this. What's the next step? Next line? Okay, so all I need you to really give me is the next line when we're solving. Every one of these problems is going to end up having an algebraic equation that you have to solve. So I don't need you to tell me how to do it anymore. Just give me the next line. In other words, when you subtract 8 from both sides, the next line is 3x equals 12. Now give me the next line. Okay, and there's your answer. Okay. If they want to find angle CBD, what does this diagram mean? What is that hash mark? In other words, we have an angle sign there. We have an angle sign over there. What's that hash mark mean? Yeah, exactly. So that one's 27 degrees. And it's asking what CBD is. So that's as easy as they come. Okay. Number 3. They want to know MNQ. They want to know MNQ. And they're giving you the arc, not the length, but the arc angle. So what's true about MNQ? What's true about this angle right here? Exactly, they're equal. Now let me make it a little clearer. Whenever you have a circle, Okay, and you have the center of the circle. Whatever arc measurement, in other words, if that's a 90-degree angle, then this is 90 degrees also. The measurement of that arc. Now, that's different than the measurement of that length. The length of this section, if this were a piece of string, that's totally different. But the measurement of the arc length always equals the measurement of the angle if it's a central angle. Okay, hold on, let me scroll up so I get some writing room. So we got to find the value of the variable, which is x, y, and z, and the unknown angle measurements. There's lots of angles here that we can label. So first of all, let's start with x. What is the measurement of x and y? Why? Do you know the name of it? It's because of vertical angles. Vertical angles. Yeah, same reason that 1 is equal to 2. In other words, anytime you have two lines that intersect, that one's equal to that one, and that one's equal to that one. Okay, now, based on what I told you on the last problem, what's that make y equal to? And you know what z is? Okay, well, let's look at these two angles. In order to know what z is, we need to know what these two angles are. First of all, what are they based on? Each one has a double hash mark. That means they're the same. In other words, if you have a figure like this, and you have an angle there that's equal to that angle, and there's two other angles in that figure, then you have to use two hash marks to indicate that this one's equal to this one, separately from this one's equal to that one. So we have two hash marks here, which means these two angles are equal. What must each one of them be? If I have, hold on a second, let me help. If I have a line and another line hits it, what do 1 and 2 equal? Exactly. So what I have here is a line and another line, and this angle equals this angle. What must each one of them be if they have to total 180? Okay, so that one has to be 90. There's no other number that works. In other words, one of them can't be 89, because then the other one would be 89 that wouldn't total 180. So they have to total 180 and they have to be equal to one another. And now, what does z have to be? Okay. In other words, we have two perpendicular lines. Whenever you have two perpendicular lines, you end up with four 90-degree angles. All right, let me erase all of this. All right, let's see. How am I going to figure out x in number 8? I got to figure out x, and then I got to figure out angle A and angle B. what do the sum of the three angles inside of a triangle have to equal? Okay, so give me an equation. In other words, all geometry problems eventually come down to equations. No, add all three of them together. It's all three angles that equals 180. Okay, and the third one? And that equals 180. And now we got to simplify that. So gather all your like terms together on the left side. What do you have? About the numbers. Okay. And keep going. Next line. And next line. Okay. So, x equals 40. Now what's the measurement of angle A? And angle B. All right, let's see. They want the measurements of A, B, C. That angle that we could also call just angle B. Where to begin? Geometry is almost always a case, especially when you get beyond just level 1, where you have to do other stuff to give you your answer. In other words, there's no way I'm going to get angle B directly. I got to do other stuff. Maybe I could get that angle, and maybe I can get that angle, and then those two plus angle B have to add to 180 so I could figure out what angle B is. So let's do that. Tell me what that one on the left is. This angle right here. Okay. Tell me what this one right here is. That is a linear pair with 128. Nope. Linear pairs they're supplemental. They have to add to 180. So this number, and take 180 and subtract 128 from it. Do you have your calculator, Brandon? Okay, always have that, and just remember the magic number in geometry is 180, at least in this level geometry. And so 180 minus 128 is what? Okay. Now that can give you that angle right there. What's that angle got to be? Okay, what's the sum of the three angles in a triangle equal to? Okay, so what's the sum of these two? Add 28 and 52. Do that first. That's 80. So what's angle B equal to? Yeah, exactly. Okay, I'm at number 10. D, E, F. Let me think about this for a second. If I call this angle number 1, tell me what the relationship between 1 and 5x. No, we don't need to do it that way. Hold on. I was going to do it the hard way. Let me go back a second. Let's call that angle number 1. And tell me what the relationship between angle number 1 and x plus 50 is. I shouldn't really put let me put a letter on that. We'll call it A. Angle A. What is true? You're looking at a right triangle, okay? And these two angles of a right triangle, the two acute angles, in other words, the two angles that are not the right angle, always are complementary. They add to 90. Okay? So I can say that the measurement of angle A equals, or excuse me, plus x plus 50 has to equal 90. That doesn't really allow you to solve for it. So we do have to do something else first. We have to relate A and 5x. Actually, there is a theorem that's the easiest one to apply here. Let's apply it. Let me give it to you, because it saves a step. And that is this angle 5x is the exterior angle. And no matter what kind of triangle, that angle is equal to that angle plus that angle. Always. In other words, if I have a triangle like this, and this is angle 1, and that's angle 2, and this is the exterior angle 3, then I can always say that angle 3 equals angle 1 plus angle 2. Now, that's particularly useful here because it's going to let us solve for x instantly. And that's what we need to do. So give me the equation. 5x equals what? $90 plus what? Now, solve that equation for x. Once we solve for x, then we'll know what that angle is. And once we know what that angle is, we'll be able to solve for this angle here, which is the one they're asking about. Good. Keep going. 140. I added 90 plus 50. Okay. So if we know x is 35, what is this angle right here? Well, first of all, what's the other acute angle? Right triangles are particularly interesting. You have only two angles that are interesting, and that's the two acute angles. So what's this one? D. Okay, now that we know that one, what's this little tiny one sliver that they want to know about? Angle D is 85. We'll put that one in. They are complementary, so they have to add to 90. Okay. Let's go down and apply the Pythagorean Theorem on number 11. First of all, what do those hash marks mean? Okay, so that one's also 5. What does that say about this angle and this angle? Well, they add to 90, but there's one other thing that I'm pointing out only because it's true. That's an isosceles triangle. Two sides are equal. And whenever you have an isosceles triangle, the opposite angles are also equal. So they have to both be 45. But that's not really what they're asking for. They're asking for x. What's the Pythagorean theorem say about x? Hypotenuse always the side opposite the right angle. And here's what the Pythagorean theorem says. I'm going to write it up here. C squared equals a squared plus b squared. Okay? So in our case, the C is x. That's the hypotenuse. A is 5. And b is 5. So solve that equation. Okay, so that's 50. Now solve for x. If you have x squared equals 50, what's x equal to? Okay, so it's square root of 50. And actually in algebra, it's always plus or minus the square root of 50. But with geometry, the minus you throw out, because there's no such thing as a negative dimension. In algebra, the answer is plus or minus square root of 50, but in geometry, it's just square root of 50, and that can be simplified. You don't want to put square root of 50 down there. Never want to put a radical down if it can be simplified. What can I simplify that to? Okay, you got to factor 50. Tell me what factors of 50 are, and pick one of them that's a perfect square number. First of all, let's talk about perfect square numbers. Over here on the right, tell me perfect square numbers starting at 4. Next one being 9. In other words, that's 2 squared, 3 squared, keep going. Let's keep going. Keep going. One more. Those are the most important ones to know, because almost all simplifying of radicals, you're looking for one of these numbers. Okay? So I'm looking for factors of 50. In other words, I could say that that's the square root of 10 times the square root of 5. But that doesn't do me any good because neither of those is a perfect square number. So I wouldn't split it up like that. I'm looking to split it up between a perfect square number and whatever its other factor is. Well, let's talk about factors of 50. 50 and 1. What's another set of factors of 50? The best way to do these factors is to cut something in half if you can. Can I? Okay, and then since I cut that in half, I got to double the other side. So 25 times 2 has to be 50. And now we'll do it one more time. I can't cut 25 in half, but I can cut it in fifths, which means I got to multiply that 2 by 5. So that's another set of factors. Now, do you see any perfect square numbers in there? How about that one? Okay, that means the square root of 50 can be written as the square root of 25 times the square root of 2. And the reason that's helpful is because the square root of 25 ends up being a whole number. And that's the whole object of simplifying radicals, is to try to pull out whole numbers. And that is the answer for x, and that's the only answer for x. If you were to give any other answer, you'd get points deducted. In other words, the teacher's not going to like square root of 50 because it's not simplified. Tell me whether your teacher wants your answers in radical form like this, or does she want them in decimal forms? Or does she... Good. That's the best way to do it. I hate it when teachers have you convert to decimals, because this is a perfect answer. That's the perfect answer. Is the moment you convert it to decimal, you're rounding it off. So if they ever say they want the exact answer, it means do not round it off. Okay? Now, doing right triangles is one of the most important skills you can have in geometry. Is figuring out how to do them and how to do them quickly. Okay? Let's talk about that for a second, because this is really worth memorizing. If I start with a right triangle, I know the Pythagorean Theorem says the following. C squared equals a squared plus b squared. And most everybody remembers that. And that you need to remember that. That's probably the most important theorem in all of geometry. But the thing is, when you're solving these right triangles, you're always solving for one of the sides. So if I'm solving for C, the hypotenuse, then C is always equal to the square root of a squared plus b squared. And it is worth memorizing that. And the other thing is that if I'm solving for one of the short sides, let's say I'm solving for A, well, the quick way to do it is this way. It's the hypotenuse squared minus the other short side squared. And if I'm solving for b, it's just the reverse. In other words, if I'm solving for the other short side, then it's the hypotenuse squared minus the other short side squared. So these two kind of go together when you're solving for a short side. And when you're solving for a hypotenuse, this is the one you use. Okay? So that's the hypotenuse, that's short side. So I really only need one of these to memorize. I don't need to memorize that one. So what I'm really suggesting to you is that you take the time to memorize these two on their own, separate from the Pythagorean theorem. And the reason is that you're going to have to solve about 100 right triangles in the next 3 years. It's just something that they're always asking you to do, whether you're taking geometry or any other math. You're just asked to solve right triangles all the time. Okay, so let's look at 12. It's another right triangle. They want us to solve it, only they're asking for one of the short sides. Every right triangle has two short sides, the two sides that are not the hypotenuse. So, what's y equal to? Using one of these two formulas up there. One of these two formulas there. There's your two key formulas that you want to memorize and apply. Notice that everything always starts out square root of. So, we'll start out with square root of. Now, what goes inside? First thing, when you're solving for a short side that goes inside, is the hypotenuse squared. So what's that? And then it's always subtraction when you're solving for a short side. If you're solving for the hypotenuse, it was always addition. That's the difference. When you're solving for a short side, you start out with the hypotenuse squared and you subtract what? 8 squared. Everything inside is squared, no matter which formula you're using. I'm glad they're giving you a bunch like this, because the best way to learn these is just by doing drills like this, where they give you a bunch of right triangles and you just have to solve each one of them. And most students go all the way back to that, and then there's massive amounts of algebra they have to go through. It's just easier if you memorize these two methods right here. It really is. Now give me an answer for that. How do you solve that? What's that the square root of? Okay, and what's that equal to? Okay, what's the square root of 225? What kind of calculator do you have, Brandon? Is it a Inspire or a TI-84? Okay. You have a square root key on the one you're using? Okay, so what's the square root of 225? It's a whole number. That's one worth memorizing. 15 squared is 225. So that's what y is. And it turns out that this is a very special triangle. An 815, hold on a second. So that's 15, okay? Let's talk about special triangles. When you talk about right triangles, the lowest one that has all whole numbers is 3, 4, 5. In other words, there's no such thing as a 2, 3, 4 right triangle. This is called the lowest perfect Pythagorean triangle. The next one is 5, 12, 13. And you'll see that one a lot. And then this one we just solved is the third lowest. So it actually has a special rung in geometry. These three that I just drew, you will see repeatedly. And I don't mean just 3, 4, 5 triangles. I mean multiples of 3, 4, 5. In other words, you might see a cornfield that's 30 by 40 by 50. And if you learn to recognize these, it'll save you a lot of math. All the math that we just went through to solve for 15, if you were to have recognized that as an 8, 15, 17 triangle, well, then you wouldn't have had to do any math at all. You'd have just known that that was the 15 side. Okay? But these triangles, remember, this the most important one here. You'll run into that 100 times. And in this one, you'll run into maybe 50 times. And this one, you'll run into maybe 10 times over the next few years. So those three are really important triangles. All right, now this one here. Solve for z. What is z going to be equal to? Good. They all start out as square root. No matter what side you're solving for, the first part of your answer is square root of. Even if it turns into a whole number, you still want to start it out square root of, just because it makes it easy to remember how all of them start. Good. Do that math. That's 144 minus 64. It's 144 minus 64. And now simplify that. In other words, factor it, and at least one of the factors has to be a perfect square number. Now, sometimes there's more than one. Pick the biggest one. If one perfect square number is a factor of 80 and you find another one that's also a factor of 80 but it's bigger, use the bigger one. It reduces the problem by one step. First of all, what are factors of 80? Okay, neither of those are perfect square numbers. Let's keep going. Always cut it, always cut it in half if you can. Keep going. Keep going. Double 8. In other words, I just cut 10 in half, so you got to double the other one. Okay. Now, notice in that set of factors, we've got that choice, because 4 is a perfect square number, but this is the better choice, because 16 is a bigger perfect square number. So if I'm going to factor 80, I want to factor it this way, 16 times 5. What's that turn into? No, let's square root of 16. So 4 root 5 is the answer. 4 root 5 for Z. Gotta be a little careful about some of them. Some of them, they try to disguise, make it look like a 3, 4, 5 triangle when it is not. And that's one of them right there. Because that's a multiple of 3 and 4, but it's not a 3, 4, 5 triangle. The hypotenuse always has to be 5 if you're looking at a 3, 4, 5 triangle. All right, let's see here. How are we doing for time? Shall we go to 8:30, which is 5 minutes from now? I think we started pretty close to 7:30, and don't mind giving you the full half hour, or the full hour, rather. Okay, what can I say about number 14? Again, give me an equation to write. Oops, hold on a second. Before I can write on it, I got to take a screenshot of it. Okay. They don't necessarily equal. Nothing said that AR bisected that angle. However, there are two angles that make up a right angle. So what has to be true? 3x plus 17 plus what? Equals what? Hold on, what's that angle right there? Okay. Now solve that. Okay, next one. Okay. And they want angle CAR. What's angle CAR? Yeah. Okay, number 15. What's true about those two angles? Okay, so give me an equation to write. Equals 180. Solve that one. If you can do this in one step, I don't mind. Go ahead and gather all your x's on the left side and gather all your numbers on the right side. That could be your next line if you want. If you can do that. If you can't, do it in 2 steps. Let's do it in 2 steps. Gather your x's, that's 10x. And what do the numbers on the left side equal? Plus 30. Got to put the sign in front of it. And now the next step. So x equals, and they want angle G. That's funny. That's funny. What's angle GIT? And notice we didn't need to do any of that math. They were just messing with us. We could have avoided all of that math had I just read the problem. That just shows you sometimes. I just assumed that they were going to ask about that angle or that angle, and we were going to have to solve for x. And that's fine. I don't have any problem having solved for x. That was a good exercise. But it is kind of funny that they're asking about the angle that's 180 regardless of what x is. Okay, so we'll end it there. Good luck on your test. Hopefully that hour helps. And you have a Merry Christmas and Happy New Year, and maybe I'll talk to you next semester. Bye-bye.